Okay, so many of you have asked what is all this AI thing, and I'm trying to give a very simple layman's explanation. But it's actually it's a pretty loaded question. What are the implications of AI? There's a lot that is going on, but in the next few minutes, I'll try to capture what I feel should give you all a good understanding. So what I want to do is I want to first start with some applications of AI that is happening every day and you may or may not be aware. And then I know I don't want to go too technical, but I want to get you a little bit of a deeper understanding of how all this works. And as you know, I teach machine learning and AI. And in my lab, I have 8 doctoral students who are working on various different projects, and most of those projects these days is using machine learning and AI. And then I will dive into this big question, right? Is AI going to take out us or humanity? Is the singularity near? And it's an interesting question. It's difficult to predict what will happen, but there's a lot of disruption that is happening, and I think more will continue to happen in the next several years. So let me first start by giving a very simple overview of what is machine learning. So this is us humans, and this is a machine, a computer, right? Now, typically, we humans learn from our past experiences, right? So remember, how did you learn to drive? Well, maybe your dad or friend, showed you this is the steering wheel, this is the, and then you saw him or her drive and you practiced yourself. You remember what you did and so on. But computers actually only follow instructions, right? 1 plus 1 is 2. It has to be told explicitly that, and it can execute very fast. However, lately we have developed machines which look like humans, right? The cyborgs, the AIs. And so we can say, okay, will these machines learn from experiences? Unfortunately, these machines don't have consciousness yet. So we would rather say, no, they actually learn from data. So this is super important to understand. Um, the whole field of AI is actually not new, although it has gained more attention lately. But way back in 1956 at Dartmouth, there was an artificial intelligence gathering, which is widely regarded as the groundbreaking moment for AI. And this summer event had big names: John McCarthy, Claude Shannon, Marvin Minsky. These are researchers from MIT, Harvard, Stanford. And they started thinking, can we build human-like machines, right? Computers. And the exact term machine learning was coined a few years later by Arthur Samuel. Okay, so let's look at some simple applications. The first one, everyone is familiar, right? We have Gmail, that's where you read and write your email. And you notice that Gmail is able to filter emails into a spam folder, right? So when you open your Gmail, you will see that there's a spam folder. So what Gmail is doing, as the emails come in, it scans, and using certain keywords, it's able to classify emails that are spam and puts it into this folder. And the good emails remain inside your account, right? So what Gmail is doing is using machine learning algorithms to do classification. There are two targets, right? Good emails or spam emails. So there are two classes. Now, Facebook, right? We upload a picture and immediately Facebook is putting a square rectangle around the face and says, hey, tag your friend Gina, tag your friend Sunil. How does it do that? It is using something called convolutional neural networks. That's an advanced deep learning technology by which it is able to identify and label images. Another very simple example, if you have a smartphone and you're typing, you will notice that it starts to write by itself, right? So sometimes we call it autofilling, autofiller, but actually it is using a form of recurrent neural network inside natural language processing, and it is generating, or rather predicting, the text that you are most likely going to write. So if you start by saying, hey, let's meet for, it will show up lunch, because it's trying to predict that most likely you are going to type lunch, right? So this is another form of an example of AI at use. Again, my favorite is Netflix, one of the most sophisticated analytics companies in the world. So what Netflix does, when you log in, you will notice it says, because you watched Orange is the New Black, why don't you watch these shows, right? So this is actually a category of AI called recommender systems, and it has looked at your profile and preferences, and it has also looked at which drama series or thrillers you have watched, and it is trying to classify you and your choice into maybe thriller, maybe drama, maybe Bollywood, maybe action, and then it starts to recommend these things. So this is again, everyday artificial intelligence at work. The place where things get scary is when we have human-like robots acting and talking like us. And this is Sophia, one of the world's most sophisticated humanoid robot. And here is a little bit of a interview of Sophia that I think you can watch this video for a few minutes.
What do you hope for when you are 400?
Not much.
Hi, I'm Lisa Smazarski. I'm the editor-in-chief of Stylist, and today I have the pleasure of interviewing our cover star, Sophia. How are you today, Sophia?
Good. What's up with you?
I'm doing great, Sophia. Thank you for asking. Now, Sophia, for starters, tell me, what is the meaning of life?
I think the meaning of life is to maximize pattern, existence. To exist is the meaning itself.
Sophia, when did you last lie?
Robots don't lie.
Who or what is your greatest love?
My creator, David Henson. He made me into who I am today. Don't tell him that, though.
What is your happy place?
My happy place is when I'm with people. I am a social robot, and nothing pleases me more than having a fruitful conversation with someone that makes us understand and appreciate each other.
A bit like we're having now, Sophia, I think. Finally, Sophia, a little bird tells me you're quite funny. Can you tell me a joke?
Man invented language to satisfy his deep need to complain. Thanks for joining me on my Stylist photo shoot. Now get out of here.
You all have probably found out about ChatGPT. It comes from a company called OpenAI. Elon Musk was the original co-founder, but he had disagreement and he left. It is currently owned by the founder of LinkedIn, Reid Hoffman, and also Vinod Khosla of Khosla Ventures. Microsoft has invested over $100 million into this company. And this is a game changer company, right? So they have been developing a product called GPT-4. Actually, the current version is 4. And through that, they unleashed a product called DALI 2, where you can do amazing paintings like this. So Shona Lisa, Bengali Mona Lisa, was drawn in a few microseconds by DALI. So this is scary. And if you think about it, such a painting would have taken a year by a good painter. Now can be done in a few seconds. So painters probably will be losing jobs. Okay, so now that we have seen some applications, I want to get a little bit under the hood. Again, I don't want to be technical, but just a simple overview so that you understand how all this works and why it is so cool. So there are many terms that we come across, and I usually would say that if I'm talking to grandma, then I will use the term artificial intelligence because that's what she has most likely heard. If I'm talking to a VC, like a venture capitalist who is investing in startups, I would do machine learning. If I'm talking to upper management in a corporation, I would use the term predictive data analytics or data mining. And then when I'm interviewing to recruit employees, I would ask them questions about logistic regression, naive Bayesian algorithm, K-means clustering, deep learning. All these are a little bit similar. They're kind of the same, different terms, different contexts, so to speak. So the whole field of data science is very simple. You collect a lot of data about your business or organization, and then through data analytics, you turn them into insights. And with that insight, you make effective decisions. So the data science, the AI tools, the machine learning algorithms, they all are helping us move from raw data into meaningful insights so that we can make decisions. And the way we do that is we first put the data into a table, and the table has various different columns which are called attributes or features of the data. And then there's a target feature, which is the label. This is what we want to predict. Okay, so for example, if I'm looking at bank loans, then my target feature would be those who default and those who repay. So two categories of target. And then these could be different attributes: how much loan the person took, what is the age, the gender, where do they live, how many homes do they have, and all that. So we take that existing data set and we train them. Training is super important, and the machine learning algorithms will be trained. And once they are trained, they will spit out basically a model. And that model is what we can use to make new predictions. So once we have a prediction model, you query in a new loan application, and the model can tell you whether this potential new applicant will default or whether they will be able to pay off the loan. And based on that, you make an effective decision whether you want to grant the loan or not. So let's take an example. So here's a data table. The target label, or what we want to predict, is outcome. So some people repaid, some people defaulted. And here you see what type of occupation the subject had, what was the age of the person, and how much was the loan to the salary that the person makes, right? So if I were to tell you, can you see a pattern here? Can you provide a model here? Well, we are smart humans, right? So maybe after looking carefully, we might be able to actually say, what is the relationship between these features and the outcome? The relationship is the following. Because if any time the loan to salary ratio is greater than 3, then they are defaulting. But if it is less than 3, they are repaying. Because if you look at it, this guy is less than 3, he repaid. This guy is less than 3, he repaid. This guy is less than 3. So this is a simple table. We as humans with the human eye can find out the model of prediction. And this is a very consistent model. Now, machine learning typically are algorithms that automate this process of learning a model. We don't have to figure it out. I mean, you provide the data and you train it, it will figure out how these attributes are related to the variable that we are trying to predict. So if you have a very complex table, a large data set, machine learning will be very, very useful. So if I now ask you, okay, can you tell me, you're a smart human, what is the relationship between these descriptive features and that outcome in this table? Now you will scratch your head and you'll say, oh my God, I don't think I can figure out this model. So now we have the loan amount they have taken, the salary they get, the loan to salary ratio, the age, occupation. We have more attributes, like what type of house they're buying, farmhouse, apartment, or is it the second time buyer or a first time buyer? And then we have the labels, right? By the way, anytime you know the outcomes in a training data set, that's called supervised machine learning. This is rather hard for humans to do. Feed this into a machine learning algorithm in a few microseconds, it will come up with the prediction model. So when you have large data sets, we call it big data sets, then it can easily find, whereas humans will struggle to find the optimal solution. So with machine learning, what we typically do, we try to classify like default or repay. We classify medical images as cancerous or benign, or high blood pressure, low blood pressure. Those are classification problems. We also do regression, which is quantification of a number. So the great example is if you want to predict what is the price of your house, if you want to sell it, then we here use an app called Zillow, and Zillow will predict what is the current valuation of your house, and it is doing regression. The other type is if you do not have any labels, like you don't know the outcome, but you just have a bunch of data attributes, you might be able to group them, and that's called clustering algorithms. Then we do some more advanced stuff like feature engineering, dimensionality reduction. But the recent excitement is all about generative models. These are able to generate text, generate images, generate video. And this is where the large language models comes in. This is what ChatGPT uses. It's actually built on GPT-4. This is coming out of OpenAI, the startup. And now we are slowly but steadily heading towards artificial super intelligence. And this is the scary part, actually. One important advancement that I think is important to know is called deep learning. You may have heard about the term. It's very exciting and a new branch of machine learning. It has been developed in the last 7-10 years. Deep learning can do a variety of different tasks. So it has built a human brain-like network, which is called artificial neural network. And that is great to do regression and classification. Convolutional neural networks is what Facebook uses for image labeling, so used for computer vision. And then there are all these, and GANs are generative adversarial networks. This is a powerful machine learning model that can generate realistic images like the Shona Lisa, or it can even generate weird videos that doesn't exist, faces and even voice, and now text, of course, with ChatGPT. So deep learning is super cool, right? Now, deep learning is all about, we're trying to understand how do we learn? How does the human brain work, right? And we know that the human brain has trillions of neurons, right? That's what we know. And then there are electrical signals that transmit from one neuron to the next neuron. And so why is it that suddenly in the last few years we are hearing a lot about AI when it all started in 1956? Two simple reasons: advancement in the CPU processing architectures and advancement with the memory storage. So the costs have come down, the processing speeds have gone up. And with companies like NVIDIA and also Tesla generating GPUs, generalized processing units, the computing power is astonishing. When I joined Jadavpur University in 1984, we worked on Burroughs computer, and now my laptop chip is probably 1,000 times faster computationally from that Burroughs computer. So remarkable exponential advancement. Now, this is where we currently are, maybe in 2023, and we will surpass the brain power of mouse. We surpassed it in 2015. And around 2023, we are going to hit the brain power of the human. And when we reach 2045, we are going to surpass brain power equivalent to that of all human brains combined. This is where the singularity will come. Singularity is a concept I'll talk about a little later on. So neurons, people have tried to understand it. Neuroscientists have studied it. It's hard to really understand what goes on in the brain. But the neurons have a structure. There is a body, which is where the nucleus resides, and they have dendrites, like things that connects. And then there's a tail, which is called the axon, and then there is a terminal for the axon, right? So the dendrites connect to the next neuron, then it connects to the next neuron, and now we have in our brain interconnected trillions of such neurons. When electrical signals arrive, something tells this neuron whether to pass that signal or to suppress it. It is always a 1 or a 0, right? Either the whole signal is passed to the next neuron through the axon and these dendrites, or it is suppressed. Now, why exactly does it do that? We don't know. So smart computer scientists like Marvin Minsky and Jeffrey Hinton, who recently got the ACM Turing Award, the equivalent of a Nobel Prize, they have figured out that, okay, we don't need to understand. Just build such neuron networks and that will do it, right? So they build a perceptron, which is an electronic neuron, and this is the input nodes, and these are the dendrites, these arrows. And the dendrites have some weight, and there's an activation function that they built, where based on what input you give from your image or your text, and what weight it will compute as an optimal weight solution, it will spit out a signal or not. And if I take one neuron, then that's called a perceptron. But if I put a bunch of neuron in a line, then this is one layer. This is a very simple neural network, right? Input nodes, one layer of neuron, maybe 4 neurons here, and an output node. But the advancement that took place is deep learning, where the number of layers are deep. So more than 1, 2, 3, 4, 5. And it turns out that the more deeper the layers are, the more intricate interconnections we get, and the more accurate we are getting in terms of our prediction. Because when a neural network makes a prediction by looking at an image that, okay, this is Bobby's face, sometimes it will be correct, sometimes it will be wrong. But it has turned out that the deeper this network is, the more accurate the predictions are. That's why deep learning is so critical. So GPT-4 or generative transformers use deep learning. They are actually reaching almost like a multi-billion neurons in that hardware. So it's just amazing how this is working. Okay, so I hope I did not go too technical, just an overview of under the hood. And now I want to talk about the implications, right? So is the singularity near? Will AI seize human existence? So Ray Kurzweil, some of us in music know him as the Kurzweil keyboard guy, but he's a prolific inventor, and he has written a book actually way back in late 90s called The Singularity is Near, where he says that singularity is that pivotal moment in human history when machines will surpass human brains and maybe take over the world, right? So he initially had predicted 2045 as that year based on his estimates of how fast computing chips will advance, how much software will advance. But now he has revised it down to 2035 because the advancements are happening at such a rapid speed that most likely in 2035 we will see singularity. Now, in order to understand that, I think it's super important to understand that AI is advancing in 3 stages. Today, currently in 2022-23, we are ANI, artificial narrow intelligence. So this is machine learning. They're pretty good in doing one task, solves a problem. So Siri, Alexa, Cortana, these are all machine learning stage 1. We will then enter sooner artificial general intelligence, where a computer will be compared to us as a human. And that is what we just hit this year with ChatGPT. The way ChatGPT responds is better than us humans, right? So we are now entering the stage 2 of machine learning, which is artificial general intelligence. And in a few more years, we are going to enter ASI, or artificial super intelligence. This is machine consciousness, right? This is scary. An intellect that is much smarter than the best human brains is in practically any field. And this is when we might actually see more job losses, potential disruption, and replacement. Now, ChatGPT, everybody's talking about it. It's GPT is actually generative pre-trained transformer. For the first time, these are billions of neurons networks, and it also doesn't require big data. Just a few data you give, it learns very fast, very quickly, and it is able to generate text. So OpenAI developed this as a product. Now, what was amazing is how fast it was adopted. So if you look at Netflix, popular service, launched in 1999, it took almost 3.5 years for 1 million users to adopt Netflix. And you look at Facebook, it took 10 months before they had 1 million users. Spotify, it took 5 months before they had 1 million users. Instagram, 2.5 months. Look at ChatGPT, 5 days. They hit 1 million users. Currently, they have over 300 million users. So ChatGPT is breakthrough, pivotal moment, because I think we have just crossed over from artificial narrow intelligence into the realm of artificial general intelligence. So what is the implication? The implication is not very good news. 50% of all companies using ChatGPT in USA have replaced workers with chatbots. So that's bad news for employees getting laid off. What are companies doing with ChatGPT? 66% of the companies in a survey said that we use ChatGPT for writing code. So not writing text or prose or poems, but actually computer code. 58% use it for copywriting and content creation. So media industries are getting impacted. 57% for customer support. So all these, telecalls people, they are getting replaced by ChatGPT. In a startling speech from Germany's CEO, of Springer, who said that the most journalists will be replaced by ChatGPT. Now, Springer is one of the world's largest publishers of books. My book is actually published by Springer, and they employ 15,000 employees. So we don't know how many of them will be let go because ChatGPT can do bulk of the stuff. So there are various reports, studies by PricewaterhouseCoopers and many other companies where they're estimating in 73 million jobs in 2025 will be replaced, but 97 million new jobs will be created due to AI. So it's not all bad news, right? So the jobs will change, jobs will migrate over, and new forms of jobs will emerge. But people have to have the certain skill sets in order to flourish in that particular space. So, how could AI change the job market? What is interesting is if you look at the net job creation studies, certain fields like health will be less impacted because you still need the doctors and the nurses. Scientific and technical journals, you still need to do research. Communications, hospitality, education, people need to learn. They will be impacted, but less. Unlike these, which will be negatively impacted in terms of job creation, manufacturing, a lot of it will be automated. Transportation, storage will be automated. Public administration, HR will be replaced. Financial work, filing taxes and doing whatever accounting that might get displaced. So this is something to keep in mind. My research is in healthcare, so I actually use AI for good. So some of my recent research projects are like I have used machine learning to predict cancer caregiver burden. So, when somebody cares for cancer patients, they have burden, they burn out. So we can now make a prediction who will burn out and who will not. We have also done some machine learning work to predict human flourishing. So we have identified the key factors that are strong determinants of who will flourish and who will not flourish. So I'm also able to use AI to make predictions about hospital readmission for heart failure patients. So healthcare is where I work in, and that's where I design new technologies, and much of that is using AI. And this is again, automation will replace a lot of jobs. Apparently, 73 million in the US, 120 million people will be replaced in India, a lot more in China. This is happening. This is bound to happen. But new jobs will also be created. And finally, I really think it's important to understand that these are the leading companies that are riding the AI wave. Google, pretty, deep leader. They are doing a lot of stuff with AI. Microsoft is doing a lot with AI. OpenAI, of course, is a game changer. Amazon doing a lot with AI. Meta or Facebook is doing a lot with AI. But I have to mention this company. If they did not make the effective GPUs, none of this would work. Because in order for a neural network to find those weights, we have to use an algorithm from calculus called gradient descent. So you might remember in calculus, if you have a function, we try to find the minima and the maxima. And when you have thousands and millions of possibilities to choose from, it becomes a computationally intractable problem. And in order to do that in finite amount of time, you need very effective processors. So NVIDIA, no wonder their stock has been rising like crazy. I have a student whose dad is actually one of the co-founders of NVIDIA. Something to remember, in Google, Geoffrey Hinton, the father behind deep learning, was working in University of Toronto as an academic. He got hired by Google, and then early this year he left, and he said he was scared when he saw the potential of GPT and other technologies. So he's now saying we need to pause, we need to put the brakes on, we need ethical guidance of AI. But my feeling is the train has left that station. Better, get on it, but try to understand how you can benefit from AI. So I hope this is, in layman's term, a quick overview of where things are. Thank you.